Hello everyone. This lecture will cover our budget constraint practice exercise. Concepts that will be covered are budget constraint equation, opportunity set, opportunity costs. We'll go through those concepts through mathematical formulation and graphic depictions. The thing to notice on our diagram is table is on our x-axis and chairs are on our y-axis. We also have a few other information. The budget is $200. The unit price for chair is $10 and the unit price for table is $20. So we begin here by trying to establish our budget constraint equation. First, let's try and explore the information given so far. We know that the unit price for chair is $10, and the quantity of chair purchase will be denoted C. The price for table is $20. That will be the unit price for table, and the quantity of table will be denoted T. And we also are given a budget of $200. So what we need to do next is how do we establish the budget constraint equation? The formula is given, which is total purchase will be equal to the budget, which is the price for table times the quantity of table purchase plus the price of chair times the quantity of chairs purchased. And that leads us to $200, which is the total budget, will be equal to the unit price of table, which is 20, times the total purchase of table, plus the unit price of chair, which is $10, times the total purchase of chair, which is letter C. And eventually we'll arrive to this budget constraint equation, which is 200 equal 20 times the quantity of table plus 10 times the quantity of chair. So in your assignment, this is the expectation in terms of what the budget constraint equation will look like. We can now use the budget constraint equation to determine opportunity sets. Here we can begin by asking the question, which is how many chairs can we purchase when we have zero table? From that question, we can determine that T equal 0 because there's no purchase of table. The next step is now to use the budget constraint equation, which is 200 equal 20T plus 10C, and we will now plug the value of T equals 0 in that budget constraint equation and solve for C. And that leads us to the mathematical formulation, which is C equal 200 divided by 10 equal 20. So with zero purchase of table, all the money goes towards the purchase of chair, 20 chairs that we purchase. How do we now place those values on our diagram of x-axis and y-axis? We know that table equals 0, therefore we will place 0 on our x-axis and chair is on our y-axis, therefore 20 goes on our y-axis, and that gives us the coordinate of our bundle or opportunity set, which is x equals 0, y equal 20. To determine the next opportunity set, we will answer the following question. How many tables can we purchase when we have zero chairs? And that very question will determine that C equals 0. We'll go ahead and use the budget constraint equation, 200 equal 20T plus 10C. We will plug in the value of C equals 0 in that equation, and then we'll solve for T. and that gives us the formula, which is T equal to 100 divided by 20 equal 10. And placing those values on our diagram will give us table, which is on x-axis, equal 10, and chair, which is on our y-axis, equals 0. So that gives us the bundle D with x equal 10, y equal 0. On our graph, it's always good to at least summarize here your bundle or the coordinate of your bundle, which is x equals 0, y equal 20, and the next opportunity set, which is your bundle, x equal 10 and y equal 0. Now that you have the coordinate of two opportunity sets, you can place those on your diagram based on those coordinates. And having 2 points, you can now draw your budget constraint line. The next concept would be opportunity costs. Here's the question. How many chairs do we lose if we increase the number of tables by 4? It is important to understand what is opportunity cost. For instance, as shown on the diagram, as we increase the number of tables from 0 to 4, we will lose some chairs from 20 to 12. So let's go through the process of being able to read information on the diagram to be able to determine how many chairs do we lose when we increase the number of tables by 4. It is important to have some understanding of algebraic expression and graphic reading. We have our algebraic expression here, which is an increase of 4 tables is denoted as shown here, delta t equal 4, and the decrease in chairs is denoted delta c, which is the value that we are trying to determine. The change in table is 4, and the change in chairs is what we ought to determine. Let's begin our graphic reading. We can read on the graph that for x equals 0, the corresponding y value will be 20. And that's what we read on our graph. We can also read that for x equals 4, the corresponding y value will be 12. So we can therefore observe that an increase in tables goes from x equals 0 to x equals 4. And a decrease in chairs goes from y equal 20 to y equal 12. We now can summarize our observation by saying that an increase in table is determined by computing 4 minus 0, which is 4, and a decrease in chairs can be computed by having 20 minus 12, which gave us 8. So we can now conclude that an increase in table by 4 leads to a decrease in chairs by 8. And that will be the answer of the question, which is the opportunity cost to increase the number of tables by 4 is 8 chairs. Hope this was helpful to understand the process of using information graphically to answer questions of opportunity cost.